In this video, we are going to learn how to write an equation of a parabola. So what is the equation of the parabola in standard form that contains the given points? So we're given 3 points, which is enough to find the equation of any parabola. So now we'll see here that the way you do this is we'll use standard form, since it wants it in standard form. And we'll just substitute these points in for x and y in the standard form equation. So, for example, for 0, 0, I can plug in 0 for y and 0 in for both of the x's and solve that equation, which turns out to be 0 is equal to c, so c is equal to 0. But if I do this 2 more times, I'll get 3 equations involving a, b, and c that I can set up a system of equations for. So continuing this forward, if I plug in -2 for y and -1 for both of those x's, I'll get -2 is equal to a times 1 minus b plus c. So I'll get a minus b plus c is equal to -2. Now I'll plug in 6 for y and 1 for the x's. And now I'll get 6 is equal to a times 1 plus b plus c. So a plus b plus c equals 6. Now I have a system. C is equal to 0. A minus b plus c is equal to -2. And a plus b plus c is equal to 6. Now what's really nice about this 3-variable system is one of the variables is already solved for. So I can create a new system by plugging in 0 for c, which means I'll have a minus b is just equal to -2, and a plus b is equal to 6. And now I can solve for a and b in the smaller system, since I already know what c is. Now I can really easily use elimination here. So I'm going to add these two equations together, get 2a, the b's cancel, equals 4. So a is equal to 2. Now I know what a is equal to 2, I'll go back to one of these equations, and I'll have a minus b equals -2. But since I know a is equal to 2, I'll now have 2 minus b is equal to -2. Negative b equals -4, so b equals 4. So the solution to this system is 2, 4, 0. But what I'm more interested in is writing that standard form quadratic equation it wants us to write, which if I was following standard form, ax squared, so it'll be 2x squared plus bx, so plus 4x plus c, which is 0. So my standard form equation is 2x squared plus 4x. Now, let's try this again on another example. This time, I'm not going to give you what c is right away. So I'm not going to use that x equals 0 point. So we'll have -2 for y and 1 for the x's in one of them. So that gives me -2 is equal to a times 1 plus b plus c. So a plus b plus c is equal to -2 will be my first equation, which I'll write right here, the system. And then I'll plug in -2 for y and 2 for the x's with that point. This gives me -2 plus, equals a times 4 plus 2b plus c. So that gives me 4a plus 2b plus c equals -2. So there's another equation. And lastly, I'll plug in 3 for x and -4 for y. So we have -4 equals a times 3 squared plus b times 3. Again, following that standard form of a quadratic function, plus c gives me -4 equals a times 9 plus 3b plus c, giving me 9a plus 3b plus c equals -4. That's my last equation. And now we have a 3-variable system, which is also set up for elimination pretty well by getting rid of the c first, which should usually be the case since there's never an x by the c. That you should always have this just plus c, which should be very easy to eliminate. So what I'm going to use is the first and second equation to eliminate c by multiplying the first equation by -4 and keeping the second equation the same. I get -4a minus 4b minus 4c equals 8. And then I get, I'm eliminating a here instead. But maybe that's the strategy. So let's go with that instead. So 4a plus 2b plus c equals -2. The a's will cancel, and I'll get -2b minus 3c equals 6. And that'll be a fourth equation I just discovered. And then, since I accidentally eliminated a instead of c, I must have had that in the mind, I'm going to eliminate the other a as well in the third equation. But this time using equations 1 and 3. So I'll multiply equation 1 by -9 and keep equation 3 the same. Give me -9a minus 9b minus 9c equals -2 times -9, which is 18. And my third equation is 9a plus 3b plus c equals -4. Adding straight down, I get -6b minus 8c equals 14. And these are all divisible by 2. So if I divide them all by 2, I get -3b minus 4c equals 7. That could be my fifth equation. Now I'll set up another system with those two equations, which will be -2b minus 3c equals 6, -3b minus 4c equals 7. And now I need to eliminate one of those variables with equations 4 and 5. So what I'll do is I'll multiply the top equation by -3 to give this a positive 6b, and positive 2 by the fifth equation to give this a -6b to eliminate the b variable next. So 4 times -3 and 5 times 2 gives me 6b plus 9c equals -18. And then -6b minus 8c equals 14. Add straight down, and I get right away that c is equal to -4. Now going backwards, I can figure out that b will be equal to -2b minus 3 times -4 by replacing the c equals 6. So -2b plus 12 equals 6. Subtract 12, -2b equals -6. B is equal to 3. And then I can use B and C to find A, which I'll use that first equation up there. A plus 3 plus -4 equals -2. So A minus 1 equals -2. So A is equal to -1. Giving me the standard form equation, -x² for the A, plus bx, so plus 3x, then plus c, which would be -4. Again, if I wanted to check that this was the correct solution, I could just plug any of these points into it and see that it is correct. Like for example, plug it in 1. I get 1 squared, which is 1, but negative. So -1 plus 3, which will give me +2 minus 4 gives me -2. And I can check all of the points that way just to be sure that I am correct. And that is how you write an equation of a parabola.